Hello and welcome to our science class today. This probably means if you're watching this that you weren't able to come to our virtual meetup, and I'm sad that I didn't get to see your face, but hopefully I will get to see it next time. So we're going to get going today, and we are going to talk about matter. Okay, so we've already kind of discussed what matter is, but specifically today we're going to talk about how it's measured. So, for our welcoming ritual, I want you to word vomit everything you know about matter. So, just one word vomits, meaning matter is this. Okay, so I want you to pause the video, think about it for a moment, and then tell your parents, tell your siblings around you, what do you know about matter? All right. We know that matter is anything that has mass and takes up space or volume. And we're going to talk a little bit more about that today. Matter is anything that has mass and takes up space. So what is mass? Mass is the amount of matter in an object. So it's all of the matter that we can measure in an object. This mass is the same no matter where in the universe the object is located. So it could be located on the moon, it could be located at the very bottom of the ocean. No matter where it's located, it's going to have the same mass. But if we're talking about weight, that'll be different depending on where the object is located. If the object is in space, it's going to have less weight because there's less gravity pulling it back down to the planet. The only way to change the mass of an object is to change the amount of matter that makes up the object. So I want you to think about that for a second. The only way to change the mass is to change the amount of matter, which means if we can say we had a large rock, right? We had a large rock. The only way to change the amount of mass of that large rock is to split it in half. And now I have two smaller rocks, okay? The mass doesn't go away. It just changes. It was one big rock that was maybe pretty heavy, and now it's two smaller rocks that are less heavy, but together they're still the same mass of the first rock. And so I included two little measurements over here. The bottom one is actually the scale that's used for measurement. And a lot of times we think of that balance measuring scale at the top, but when we measure mass, it's going to be in grams. So we're going to use that bottom scale. So what's the difference between mass and weight? What do you think the difference is? Well, weight is a measure of the gravitational force on an object, and we just talked about that, right? So it's the gravity pulling the object back down towards Earth or whatever planet it's on. An object's weight can change depending on where it is in the universe and what planet it might be on. Okay, so then we're going to talk about this really quick. When we are looking at an object and we are seeing its mass, we have to measure it different ways, right? For a solid, like this rock in the picture, you can just put it straight on the scale, right? It's not going to go anywhere. We can put the solid directly on our balance to see how many grams it is. For liquid, we're going to need a container to put it in. So we're going to have to measure how much that container, how much mass is in that container, and then put the liquid in, and then measure it again. Because we don't want to know the mass of the container. We just want to know the mass of the liquid. So we're going to have to take how much mass is in the container and how much mass is the liquid plus the container. And so what we'll do is we'll do liquid plus container, so that's going to be one of our measurements, minus the container, and we're just left with the liquid. And then for a gas, it's going to be the same thing. We're going to need a container, and we would do the same thing. We would take the gas plus the container, okay, so that measurement, and then subtract it by just the container to get the gas. So let's talk about conservation of matter, okay, or mass. This is so important. So really focus in when I tell you this. Listen, matter cannot be created or destroyed. It only changes form. So I want you to think back to that rock that we talked about in the beginning. No matter ever left when we cut it in half. If we put it back together, it would still be as heavy as it was before. But since it's in half now, we have two objects that weigh less than the original object, but if we put it back together, it would weigh the same, okay? So it just changes forms. It's two small rocks instead of one big rock. So I want you to think specifically about an ice cube, okay? So we see ice cubes in this picture. So think about an ice cube as soon as you take it out of the freezer, okay? So it's very solid, it's cold, it might stick to your fingers. Now what would happen if you put that ice cube on the counter and watched it? What do you think would happen? Well, obviously, you probably know it's gonna melt, right? Eventually it's gonna melt. And as you watch this ice cube melt, the mass never goes away. And you might be thinking, Miss Stokes, the mass does go away because it was a hard solid and now it's a liquid. And it's not as heavy, or it's not as, it doesn't have that same amount of matter in it that it originally had. But that's not true. So when we have the ice cube, okay, and it melts, all that liquid is the same amount of stuff that was in the original ice cube. And we could, if we could, scoop it all back up, if we could clean off the counter and scoop all those little bits of water back up and refreeze it, it would be exactly the same as our ice cube was in the beginning. So this might help you think about it a little bit better when we're thinking of the law of conservation of matter. 2 graham crackers plus 1 marshmallow plus 1 chocolate equals what? That equals 1 some more, okay? 1 s'more. Now, did any of those ingredients change when they became a s'more? And you might think, well, it tastes very different if you have them separately and together. Yeah, it definitely does. But those ingredients are still the same. They've just changed their form to now be a s'more, okay? So now we're going to talk about volume. Okay, so what is volume? We've been learning about it in math. Volume, as seen here, is the space something takes up, okay? So when we're talking about it in math, right, we're talking about 3D objects and we're talking about filling them to the top, okay? So the amount of space that object takes up. Now, when we're talking about science, it's the same thing, okay? We're still talking about the amount of space something takes up, but it might be a little different. We might be talking about a liquid. We could be talking about a solid, or maybe even a gas. So I want you to do this. I want you to imagine a speck of dust. Even the tiniest speck of dust takes up space. Another speck of dust cannot fit into that same space without somehow bumping the first speck out of the way. So when we're talking about volume, the liquid, solid, or gas has a specific space that it takes up, and nothing else can take that space. So we need to be able to measure that. And we measure that by finding the volume. So how does the volume or shape change with the different states of matter. Okay, so in these containers, we see the first one has a solid, the second one has a liquid, and the last one has a gas. The first one, when we put that solid into the container, what does the solid do? Does it change at all? No, it doesn't, right? Its shape stays the same, and its volume stays the same, okay? So it occupies a certain amount of space, and that stays the same. And also, it's not going to change shapes unless it's an ice cube that decides to melt, right? And then it would be a liquid. In the second container, we have a liquid. And think about filling up a container. Think about filling up a circular container versus filling up a square container. Is that container going to change the shape of the liquid? So it will, right? Depending on the type of container you put it in, the shape of the liquid conforms to the shape of the container. It fills it in on all sides, right? So like this container that we see here, we could keep filling it all the way to the top and maybe even overflow it, right? But we can only contain liquid with a container, which means that it doesn't have a shape by itself. And then it also has a specific volume, okay? So the amount of matter in it is going to stay the same. And then here we are with gas on the very end. Gas completely fills the container it's in. Why do you think that is? Well, without a container, gas would just be loose in the environment. They're very small, and we'll talk about this at some other time, but it's very small particles that bounce around, okay? And so when we're talking about those small particles, they can't be contained unless we put them in something. So finally, here's our optimistic closure. What do we use to measure matter? So we've talked about two things. Can you think of those things? Hopefully you said mass and volume. Mass and volume. And then to go even deeper and dig deeper into your mind, ask yourself, what is mass? What is volume? And then answer those questions. All right, you guys did great today. I am thankful for the time that you spent with me. Remember that you need to go take your quiz as soon as you're done watching the video. All right, I'll see you guys in class soon.